This is section 10.4 and today we're going to finish up our conversation with inscribed angles and polygons. Today we're moving on to the polygons part. So a polygon is inscribed if the vertices are on the circle. Like these ones. I have a shape inside the circle, but the vertices, the corners of the shape, are actually on the circle. So they're totally contained. When that happens, the circle is called circumscribed, meaning that it totally, my light turned off, there we go, it totally captures the shape with its corners on the circle. So over to your theorem card, we have two theorems today. Ignore this part right here, that's a note to myself. If a right triangle is inscribed in a circle, so if we can get a right triangle in there, then the hypotenuse is the diameter. So meaning as soon as I get my triangle into half of the circle, that's going to be a right triangle every time, and AC is going to be the diameter of the circle. Our other theorem for today says a quadrilateral, can be inscribed in a circle if and only if its opposite angles are supplementary. And if you could put a giant star by this theorem, this is for sure one that kids get wrong all the time, because we just got finished with a unit where in a parallelogram opposite angles were equal. These aren't parallelograms, they're just four-sided shapes, they're just quadrilaterals. So the opposite angles, like E and G, together would equal 180. F and D together would equal 180. So they don't equal each other like they did in parallelograms, and that is really common for students to set them equal to each other. So back to our notes packet, just a couple of examples. So here I've got a triangle. We've managed to fit it into half of the circle. I know O is the center, AB is a diameter. That automatically makes that a 90. And I know in a triangle there's 180 degrees, so 180 minus that 90 minus that 55 gives me 35 for this angle right here. Oh, sorry, your notes packet has the X right here. I don't have mine written in. And then we know from inscribed angles that if that's 35, that makes our X 70 degrees. Next up, we've got our first quadrilateral inside of a circle. So we're going to take our opposite angles, we're going to add them up and equal 180. We're going to take our opposite angles, add them up, and equal 180. So just two different problems for us to solve. We've got 4a's equals 180. Divide by 4, a is 90. Oh my gosh, I can't do math. A is 45, sorry. 2b plus 4b is 6b. Divide both sides by 6, and b is 30. Next up, I've got another triangle in a circle. I know G is the center. They put a dot there for me. That makes AC a diameter. Makes that a 90. This angle goes out to that arc, which I don't know anything about yet. I know this is 120, and I know that that diameter makes 180, which means there's 60 left for that arc. And to bring it back inside the circle, we cut it in half. Oops, so this one will be 30. Last one, again, opposite angles, so 10 and 8x equal 180 together. And then I've got C and 2C minus 6. So I'm just adding both of those angles together and equaling them to 180. So x is 10 on that side. Over here I'm going to add my C's together and get 3. Then I'm going to add the 6 to both sides. And then I'm going to divide by 3. 186 divided by 3 is 62. I was just making sure I typed that in right. I did. So there are both of your triangles and your quadrilaterals inscribed in a circle.